Hello everyone, this is Miss Alma May Bernales. In this video, we will talk about algorithm design. The objectives of this video is to identify the steps in the design and analysis of algorithms and differentiate pseudocode from algorithms. Before we dig into the steps in designing algorithms, we should define first the algorithm. So according to Rosen 2012, in our previous class in discrete structures, the algorithm is a set of step-by-step solutions or operations to solve a problem. So they are expressed in a finite amount of time and space. We can also implement an algorithm for a specific problem in any programming language. This means the algorithms are programming language independent. So these are the steps in the analysis and design of algorithms. First is to understand the problem. In this step, you will identify what are the inputs of this problem, then what are the expected outputs for each input. It's the same as solving a math problem in which you are to find what are the given and the result for the given and how you solve it. The second step is to establish the capacity of computing device. So the computing device that we are referring are technologies that can process or interpret a set of digital instructions or programs. For example, computer, laptop, smartphone, etc. Sequential algorithms are algorithms that work on machines which execute instructions one by one. Other algorithms are designed to run some of the instructions simultaneously or concurrently. We call these algorithms as parallel algorithms. In this step, you also need to choose between optimizing the algorithm for its runtime or its space or memory requirements. So, we know that each computing device has the following has different memory requirements or space, and also some computing device can run on parallel algorithms. So that's why you need to establish what the capacity of the computing device. The next step is to choose between the exact and approximate algorithms. So the exact algorithms are algorithms that produce the exact answer to a computing problem. For example, in sorting problem, you will need to sort as a set of numbers or characters. So if you find even only two um, number in that set that are not in order, that means your result is not correct since it really needs to be in exact order. On the other hand, the approximation algorithm only has approximate or estimated computing problem. Okay, so the results of these algorithms are just estimates. The applications to these algorithms are complex problems such as classifications, extracting square roots, diagnostics. For example, you will need to identify if a person is COVID positive or not. You can only determine if it's 90% chance that he is positive, then the result will conclude that he is really positive. So it depends on the percentage of likelihood. The fourth step is the algorithm design technique. So in this step, we will need to determine what design technique to use. First, we will define what is an algorithm design technique. So according to Levitin, it is a general approach to solving problems algorithmically that applies to a variety of problems from different computing areas. Since this is a broad topic, we will discuss some of the algorithm design techniques in the later part of this semester. The next step is to design an algorithm with its data structures. So, if you recall in our previous subject, data structures and algorithms, I have emphasized that in that subject that we cannot separate data structures from algorithms. It is because data structures play an essential role in designing an algorithm. Remember that you need to note the advantages and disadvantages of different data structures to determine what will be the appropriate data structure for a specific algorithm. Um, the next step is to specify the algorithm. So we can specify algorithm in two ways, pseudocode or flowchart. Your previous computing classes have already introduced flowcharts. It is a tool of visualizing your algorithm using shapes, and the use of this tool is to emphasize the flow of the algorithm. In contrast, pseudocode is an informal and human-readable description of an algorithm. We have introduced this in the last topic of our discrete structures class. So writing pseudocode has no restriction of styles, and its only objective is to describe the high-level steps of the algorithm in a much realistic manner in natural language, realistic in a way that it is already like a program. The seventh step is to prove the algorithm's correctness. To do this, you need to establish that the algorithm will always yield a precise output in each valid input. Note that correct outputs for some random inputs cannot substantiate the correctness of the algorithm. A standard method in proving the algorithm's correctness in exact algorithms is to use mathematical induction. We will not cover this topic in this subject, but it is worth mentioning for future references. However, only one counterexample will prove that your algorithm is incorrect. A counterexample is an example or one instance that will confirm that your algorithm fails. That is why when you check your algorithm, even if it fails in only one instance, that will not be the right algorithm for that specific problem. For approximation algorithms, since the results are estimates, we use accuracy assessment in determining its correctness. We can say that the algorithm is correct if the errors it produced does not exceed a predefined limit. For example, we can say that your algorithm for diagnosing COVID-19 is correct if it is at least 90% accurate. The eighth step is to analyze the algorithm. You might ask, how do we choose from algorithms which solve the same problems? That is after proving that algorithms are correct. One way to select the best among the algorithms is considering their efficiency. There are two kinds of algorithm efficiency. First is time efficiency, which determines the runtime of the algorithm. Second is the space efficiency, which indicates how much additional memory it consumes. In the next topics, we will discuss this in detail. Last step is the coding of the algorithm. When you code your algorithm, it allows you to conduct a practical analysis of the underlying algorithm. You can check whether its outputs are correct, including the time a program takes in running several inputs. Then you can analyze the results of these executions for various inputs. In the next lessons, we will discuss the pros and cons of using empirical analysis in analyzing algorithms. We will continue our discussion in our next video. Thank you.